Hey, hello, welcome to the show. It's me, John Park. It's time for John Park's Workshop. Look, I'm so excited about the scroller thing I built the other day that now I'm putting all sorts of stuff up there. Thanks for stopping by. Thanks for stopping by over into our chat. We have the YouTube chat. Hello, Beata Graf Avdalhagen, Dave Odessa. Is this YouTube? Taif Gundry. Great to see you all there. The other chat, if you're somewhere that doesn't seem to have one running, is over here on this mirror world. No, wait, it's on Discord. Let me fix that. And that right there, there's our Discord. It's at adafruit.it/discord. Hop over there and look for that live broadcast chat. And you can come and hang out with these good people. Hello, Andy Calloway, Yanisku7, Johnny Bergdahl, Jim Hendrickson, Finman, Squid.jpg, Andy Calloway, Blitz City DIY. Hello. So I'm not sure if the Facebook has gone live. Something's gone weird there. I don't know why. I gave it a stream key and all those good things, and don't know why. So if you somehow get this message and you don't know where to watch, go to YouTube or LinkedIn or Twitch. One of those places. Don't know what's up there. So what is this? What is this GIF? Is it a VR guy? A VR guy. So what's going to happen today? Well, I've got a shorter show today. I got busy with some things, so I don't think we'll be doing a CircuitPython Parsec. I do have a coupon code for you. I've got a recap of the product pick of the week. I have a little bit of a show and tell with the espresso tank meter project enclosure. I've got a new project I'm kicking off, which is the USB MIDI Host2Host, which is different from a different USB host project I did. This is a different thing, but hopefully I'll be able to show you why with a little demo this matters and exists, what it's for. And that should be it. So let's start off with, this coupon code. You know what? Let me check and see. I think there may be a better coupon code to use because I just realized I think there's a 15%. Is that good now? Let's, is that only on some things? Give me a moment here. Sorry, we had some stuff going on. I wasn't able to check this. Well, I'll tell you what. Use this unless you find out otherwise. So that's my coupon code for the day. It is 10% off. It's Fugue State. That will get you 10% off in the Adafruit shop on anything. We may have a 15% off Valentine's Day one. I saw tell of it, and I'm just not sure if that's on a limited set of things or if it's in effect right now. You can usually just head to adafruit.com and look for the banners to see if there are other discounts. I think some of them may show up in the checkout as well. But you're armed with this at the very least. You've got Fugue State, your 10% off discount coupon code for the day. It's good until midnight tonight. And if you head over to, oh, this is going to be broken too. Sorry, I have a whole bunch of, my machine threw away a whole bunch of selections I had made. Let me resave this file while I've got it. Maybe that'll make it happier. So that right there, that's adafruit.com. If you head to Products banner menu item at the top, click on View All, you can see some of the neat new stuff we've got. These just came into stock, this snap-on mount for an Adafruit CircuitPython, which doesn't have mounting holes, right? It's based on the JPPPoW, the Seed JPPPoW board, which is meant to be as small as can be, and so there's no room for mounting holes on the PCB. But sometimes you want to mount it on something, and this is a way to do it. It's a neat little snap-on case, and then it has 4 screws on there. These are SLS printed, or SLA printed, and you can use, does it say? I think those are M2.5, possibly M3. Yeah, M3, 4 M3 mounting screws. So that's a new one. Got a few of those in stock. You can get 10% off on a handful of those, and we also got in a whole bunch of these fans. If you have just a need to plug a fan into USB power or USB battery pack, maybe just bring it on the airplane and cool yourself off, do it low-tech style, then you can get one of these. We have them in a bunch of different sizes. And there's a few other cool things. In fact, we still have a few of these gigantic outdoor LED NeoPixel netting displays, and you can get 10% off of one of those. This is a good time to grab something big like that, get yourself a discount. Don't do it on a day when there's no discount. Do it now. Other thing I'll mention, besides reminding you that Fugue State is the coupon code today, is you can also get some free stuff. If you head to adafruit.com and type in /free at the end there, you will get a few enticements here. We can give you a free PCB coaster with the Adafruit logo for spending $99 or more in the store. If you spend $149 or more in the store, you'll get the coaster plus a KB2040. And then if you spend $199 or more in the continental US, you can get free UPS ground shipping, as well as the KB2040 and the coaster. So go check those out if you're ever curious, adafruit.com/free. That'll tell you more. And most of these links, by the way, are at the very bottom of the page. You can see here's freebies, there's questions about shipping and returns. This is all pretty much the site map plus these up here. All right, so that's the coupon code for the day. Ooh, you know what? You know what would have been slick? If I had thought of this. Let me go over to my Messages app. I can change that display by typing in text, comma, Fugue State. If you didn't catch this on my show about the Matrix Portal S3 on Tuesday, which I'm about to show you a little 1-minute edit from, this is internet connected using the SMS power-up on Adafruit I/O. I have a special number that I text to, and then every 20 seconds or so, I think, this will check Adafruit I/O to see, hey, do we have any new messages to display? So while I've been stalling here, it should be, excuse me, get a drink. Headed up there, and it grabbed the coupon code. So there you go. Maybe that's my new way of posting the coupon code. Probably both. Probably do both. So without further ado, let me show you my little 1-minute excerpt from this right here. Product pick of the week. Here comes the recap. Is the product pick of the week this week? It is the Matrix Portal S3. Matrix Portal S3 is just here on the back. It is not plugged into the computer, but I can use my phone or my Messages app through the SMS power-up, a text message to that board through Adafruit I/O. I'll type in text, matrix portal S3. I just texted that to a number that I was assigned by the SMS power-up on Adafruit I/O. Matrix Portal is going to go check Adafruit I/O to see if there's any new messages. In this case, you can see we got it pretty quickly. And I just have it set up with a cool little scrolling messages app and library or code and library in CircuitPython. There is my product pick of the week this week. It is the Matrix Portal S3. All right, that's what that is. What else have we got? So I mentioned no Parsec today. I'll get back on the regular with those next week. So we can move on to another couple things. One of them is I showed this on Show and Tell last night, but I want to talk a little more about, this is the newly printed backing for the Espresso Tank ultrasonic sensor. Previously, I had been dropping the sensor down on top of there, and then I was going to build a cover for it. Realized I ran out of room because you might have seen last week when I had the water reservoir, my espresso machine tank open, it hinges down and it just cleared the ultrasonic sensor, but I couldn't really put a little additional case on top of it. So I instead mounted one underneath it, changed the design a little bit so it sits under there. So this is flush with the top, and I'm just going to transfer it over to this one because these holes are just an artifact from the previous design. So it'll look more like that and give us at least a little bit of splash proofing there. I've got, this is, while I'm pouring water in here, excuse me, it's not a ton of churning and things, so I'm not too worried about this. You could plug that. This is going to be covered. You could take extra precautions if you needed to. But I think we're going to be okay. And then this is, let me drop down to the down shooter for this, in fact. See a little better there. So there's the sensor poking down, and that's what the top will be. So that'll look like when it's covered. This is a little cable I made to plug in right here. This is not keyed, so you have to pay attention. I put some marks on there, and there are matching marks on the board, colored marks on the board, red and black for the red wire, green wire of that. So that'll plug into there. This just has a little heat shrink on it. And then this runs over to the, oh look, the magnet is grabbing. Oh, I wondered where that screw was. The magnet's grabbing screws. These are little magnetic feet we have, so that sticks to the back of the machine. And then I've still got some access points here for the boot select and reset buttons. This is a Feather ESP32 S3. Is that what I have on here? S2. And we can see the LED glow through on there. If we flick this on, I've got the little power switch there. See it booting up. The LED is quite visible. Actually, it's probably going to fail right now because it's not plugged in to the sensor. Let me plug that in. Just cycle the power there. The battery just slides in here, so I've got a little cover I put on there. You can see it's just checked the distance, which it was facing down, so it thinks the water is very, very full. And this plugs in here. I didn't hide this wire, which we probably could if we wanted to, but just fits in one of these nice 2000 or 2200 milliamp hour batteries, and you can plug in USB-C right there, and that'll charge the battery. So that's the design there. I'll be publishing that along with, I just published the code for this, put that up on GitHub in the Learn Guide repo, and then I'm going to be shooting photos and wrapping up the guide for that. So obviously it'll work great if you have the identical espresso machine I have. Otherwise, you'll probably do some modifications. Could be for anything. Doesn't have to be espresso tank. Could be any any volume of liquid that you want to measure from the top with the ultrasonic sensor. That'll be out there, so you can modify that for your needs. All right, next up then, I want to get into this USB host-to-host thing. So let me start off by showing a couple of things here. So this was the original project Todd, Kurt, and I did 5 years ago. It was a pair of Trinkies, excuse me, and it, you can see, connects their TX and RX pins and ground, so the two can talk over UART. And this is a really neat trick. It's been used particularly in the MIDI and USB MIDI world on everything from teensy boards to these Trinkies to Xiao boards to RP2040s. And the main goal here is to take two devices that can be a USB host and get them to talk to each other. And I'll kind of go back and forth between some examples there and showing and telling. So here's a typical MIDI keyboard. It can use classic MIDI, but for the purposes of this discussion, we're going to talk about MIDI. So it's got a micro B MIDI port on there, which means the A side, the square side, kind of prior to USB-C, but it still applies. A side was meant to go into your computer, your desktop synthesizer, your desktop sample station, your Groove box, your Raspberry Pi based sound computer. Anything that can be a host would talk to this as a device, and this can send its messages of what keys you're playing or other things, knobs you're turning, pressure sensitive stuff. All that kind of goes up to the host, and the host does something with it, like play music over a synthesizer engine or play back samples. The old MIDI, original MIDI, classic DIN5 MIDI, and then later TRS MIDI, that doesn't really have so much of this notion of a host and a device. It kind of allows you to plug anything into anything, and you can generally sort it out. USB has a lot of advantages, but one of the disadvantages is there's more of this class compliant device thing versus host thing, which means you can't do some stuff you really want to do. For example, and I'll show this in my example over there in a second, the phone has a bunch of great sequencers on it, along with synthesizers. Let me pull up the one I'm going to talk about. This one here, oh, that's just a bright light. This one here, Fugue Machine, there we go. Fugue Machine allows you to set a simple little pattern of music, like a classical round or a fugue, and then build complexity by playing it with multiple playheads, essentially, running through that piano roll, forward, reverse, some inversions, some interval offsets, some octave offsets, and you can play some really beautiful music in somewhat the style of a Bach fugue from this. But I can't plug this into my computer and play back a software synthesizer typically, or a desktop synthesizer like a little Raspberry Pi based thing that I'll show you. I keep gesturing back there, but I'll show you an example. That thing right there, that is a Shield XL. It is a version of the DIY Norns Shield, and I'll talk about that. You can't easily hook these things up without having some intermediary, because two hosts aren't designed in MIDI USB to want to talk to each other. So that's the goal. So this was something that Todd and I put together, like I say, about 5 years ago. And it's a fairly straightforward Arduino sketch. You can see right here. And we had little instructions at the top here. It just said connect the grounds, and then you're basically swizzling TX and RX. So TX goes to RX and RX goes to TX. And then the code uses both USB MIDI and UART MIDI at the same time. So it brings the host data over USB and then sends that out as device data over the UART serial, and then vice versa. We can go in the other direction. So there have been a few cool versions of this. One I know of also from Steve, who made that Norns shield I showed, is this one right here called Toast, which wins for best name. And this is the same idea. It's very similar actually to what I'm going to show in that I'm using a couple of QT Py RP2040s, and Steve made a custom board that has 2 RP2040s on it. I think he uses optical isolators and essentially does the UART MIDI in the middle with the USB on the sides. Here, by the way, is this, these are out of stock, but I think he's got a batch coming. If you're interested in this sort of Raspberry Pi sound computer concept, he's got bare boards all the way up through kits. And I did a lot of the work on the design of this case here, 3D printed case. If you want to get one of those, you'll see it's the same one I have here. That project is based on this one right here from Monome. Monome makes a bunch of really cool synth and related gizmos, and one of them, which I think they've stopped selling, but it was an open source one, which is this thing called Norns Shield. And the whole Norns ecosystem is a really great programmable sound computer ecosystem. Norns Shield was a shield that plopped on top of a Raspberry Pi. Steve's Shield XL is based on that. So I can throw some links in the chat for these things later if people are interested, or you can probably guess them and search them. So I believe Shield XL from Steve is also open source. It's based on the open source DIY Shield. So you could potentially grab files and make it from scratch if you want. And my model 3D printed case file is up here, as well as some other things, and then links to how to get the thing up and running once you've built it. So that's an idea of some of the stuff that we're connecting with a pair of microcontrollers. Another little desktop synth sample station that I've shown here on the show and that I use a lot is the 1010 Black Box. One of the reasons this whole thing came up again is that I had posted this version of it on the 1010 Music forums a few years ago. Someone just got in touch with me about it, and I said, you know what, let me look at, since Trinket is an older board, we've probably got some better options now for doing it with a QT Py, and that led me down this path of sort of redoing the thing on QT Pys in a couple of flavors of chips, and I'm going to write up a learn guide for it if you want to make it yourself. So that's a little explainer there. Let's go over here now, if there aren't any questions, and I will hook some things up and show you why this is cool, why I care about this. So I'm going to jump to, let's see, is that a good place? Let me put that right there. Okay, yeah, so let me head over here. The first thing I'll do is let me just give a little brief demo of this thing. I'm just going to wiggle that camera a bit. Or maybe I've just cropped it here. Let's see. Yeah, there we go. So if we take a look at this right now, and I'm going to plug in my keyboard just to show the way this is sort of meant to be used in a sense, is the host goes into the class compliant device. And I'm going to grab, oh, I have a light out. Let me see if I can turn this on. That's why it's dark over here. There we go. Grab a USB cable. So it's probably clearest when you think of it in these kind of terms. Oh, that's the wrong cable. That's not clear at all. Let me find one that is USB-A to micro B, which are becoming rarer in my workshop, apparently. Let's see, what are you? No, you're not it. You're not it. You're definitely not it. Nope. Okay, I'll steal one from one of the things that's plugged in already, I think. Sorry, we're going to spend half the show. Oh, here's one. Finding a USB cable. Okay, so yeah, it was actually physically inconvenient and annoying, but it is a little bit easier to understand when you think of the host. Usually your computer in the original USB stuff had this USB-A port. So we plug that into the host. If you take a look, here's a typical Raspberry Pi 4. It's got 4 of these little USB-A ports there. I'm running an application on here that's a little synthesizer called Molly the Poly. It's a polyphonic synthesizer. And if I plug in my device, it should power up from the host. So you may have seen some lights just went on there. So the host has powered it up, and the host is looking for data coming from this to play the synth. So let's... Okay, I gotta actually tell my host about this synth. Forgot that. So I'm gonna go to my system devices and pick, yeah, I'll pick that Arturia key step 32 as my MIDI device. So this sort of thing here, this is also part of understanding the problem. So device telling host, that's how it's meant to be used. Cool, but what I really want to do is use something way more sophisticated than this keyboard, which is my iPhone in this case, which is also a host. So if you plug in something like the camera kit on an older device, or if you have a USB-C device, at least iPads, I think you can go directly. But with typical iOS stuff, you'd use this little thing called the camera connector kit, which is essentially an on-the-go cable, OTG cable. Allows this to be the host to something like this keyboard. But that's not my goal, so I'm going to pull this out of here. I'm going to tell the device here, instead I'm using a QT-Py. So you can see QT Host2 blue. And just to keep some sanity, I color-coded these, so this one always shows up blue. This one always shows up red, and that's just something I do while I'm flashing those with their Arduino code. And so what I can do now here is plug in the iPhone, and now the iPhone has connected to this QT-Py as if it's a USB device. And if I open up that Fugue machine that was shown earlier, try to neaten some things up there. You can see I've got, and this is just a temporary box for these, I'm building a proper case. You can see I've got the two QT-Pys. I'm going to turn off the volume for a second here. So if I tell it to just play this one set of notes, you'll notice some blinking going on here. I see it at least on the red side. The blue side should be blinking too, and I think it might just be, it's not differentiating between bright and dark very well. We'll see if I could be, or it could be I only have that happening when it's on the incoming side. That might be the case. I can tell just looking at this application that it's receiving MIDI because these little sparkles, it's a kind of cool planetary conceptual thing, but these little sparkles here show up when there's incoming notes. So now let's turn it on. Ooh, I don't like that. Let me just. That's better. I'll stop that for a second. I just want to say I did not hook up a separate mic to this, so I don't know if it's going to be super loud, but you should at least be able to hear it coming over my little lapel mic here. So I'll just play with this for a second to show you, because this is just a neat concept. It's meant to sort of build up like a fugue. So I'm going to, if you look at these separately, here's what happens with that same sort of piano roll of notes. If I play, the second playhead is 1/8 of the speed, and it's an octave lower, and a second 2 semitones down. I'm going to try to get a simpler synth sound out of this. Hold on. That's probably better. Third playhead on this. Quite fast, and you can see it pings back and forth. So this would be nice to see with the original. You can add in that bass line. And then this final. Is a higher pitch, but very slow. I'm going to try a different sound. Okay, I'm going to go to a completely different synth. So the idea behind these little synth computers, like the Raspberry Pi sound computers, like the Norns Shield XL in this case, is they run a bunch of different code on them. And in this case, I'm going to use a FM synthesizer called XD1. It's a DX7, Yamaha DX7 inspired polysynth that can do, I think, 6 operators. So I'll select this. This should be simpler than what we were just listening to. And I'm going to pick a different pattern that'll be really simple. I should have started with this. So this one's called Start in Fugue Machine. 4 notes. Here's just the first. Just going to repeat that over and over. We can adjust any of these. So in this case, I'll say, oh, just play backwards. And if we play 2 at the same time that are just forward and backwards, it'll sound like this. Let me set this up. So you play backwards and same octave. And on the same tempo. So those look the same other than direction. I think so. So here's the forward. There we go. And the backward should be. Yes. So if we play them both and restart. So something I'd never be able to do with my fingers on a piano. And now you can see we've got this longer sort of sustained tone. And same sort of thing, traveling in reverse. Hopefully you can hear that. we can transpose the whole thing when we get bored of that. And stop. If we had some reverb, that would die off nicely. So I took this phone off of, put it in airplane mode so I wouldn't get things breaking that demo, but let me come back over here and just check the Discord to see if you could actually hear any of that and if you have questions. So let's see. John Carpenter's Workshop. Thank you. Getting 70s sci-fi vibes here. Right on. And now Philip Glass vibes. Yeah, it's great. I mean, it's such a nice, like there are a lot of generative music methods, but this Fugue machine, and I assume there are, or you could write your own in Lua, which is usually what the scripts are written for, somewhat separating out the sound engine. There are sound engines you can call from your Lua script, which is more the sequencer part. So you could certainly write something like this that's entirely self-contained on a gizmo like the Norns. But if I like one of these synth engines and I want to drive it from my phone and Fugue machine, this right here is what makes it possible. If I want to use Ableton Live and do piano scroll stuff in there, send it here, perfect. Anything that's a host to a host is what these little kind of gizmos are about in here. And they seem to work pretty well. This is the first time I'm trying it this way, which was a suggestion that Lamore had, which was if you look at, let me pull these out of here. If you look at my version I just put together, which is this one here. This is a couple of them on, these are M0 boards, which I soldered down to a nice little proto, which gives me a nice enclosure for it. Underneath, you can't see, there's a wire that's connecting the two grounds, and then underneath I have these two resistors running between the TX and the RX. So that's one way to do it, but Lamore said, hey, what about just connecting them through Stemma QT ports, which you're abusing to not be Stemma QT I2C stuff, but instead be ground TX RX on one and ground RX TX on the other. So what I did was I took a Stemma QT cable and very carefully lifted up the little plastic retention clip to pull out one of the wires and reverse their positions. So normally, you're probably used to seeing it like this, where you have yellow on one end, then blue, then red. You can say I removed the power. We don't want to share those. And ground. On this side, you can see I essentially made a crossover cable. So now it goes blue on the far right and yellow next to it. So that allows us to safely connect these two ports together and run the pins 22 and 23 to 23 and 22. Those are the names of those two pins in Arduino. And I've set them up as PIO. Software serial, so you can use a PIO to do software serial over those pins. Normally you can only do TX on one of those pins, you can't do RX, but software serial made that possible. I'm also realizing as I'm saying this, I could probably leave the cable alone, and probably should, and do this fully in software, because now, previously I was stuck with the one pin that could be TX, and then I was going to try to figure out RX. Now with the PIO, I think I can assign either of those to either. We'll see. If that's possible, then this could be a regular Stemma QT cable where you just remove the red wire so you're not sharing the power over there. I don't think we want to be doing that. Maybe we do. Early days, so let me know if you have thoughts about that. But this worked, and then the original, my original prototype, I put it in my pocket here, was this, which is we have these Stemma QT to DuPont pin connectors. And so there you can see a little more clearly that I've just put yellow to blue and blue to yellow, black to black. And then this you can see there's the female socket header side. Here's the plug header side. And I just put a little jumper on there to prevent that from shorting to anything. So that's the sort of original idea of doing the crossover cable. This one is a little neater, just by removing the red pin and swapping a wire. But now it's got me thinking maybe I can go one step simpler if the PIO software serial allows the TX and RX to be swapped with each other. They may or may not. I'm not sure how much of that is hard-coded into the library. Let me show that library real quick so you have an idea where this is coming from. And C. Grover says it's a null modem Stemma QT cable. Yes, it is. The questions from the chat that I didn't see. What printer are you using? Good prints too. Thank you. Those are on, I just got the Bamboo Labs X1C, I think it's called, or X1 Carbon. And it's just PLA. Fairly reasonable settings on it, and it prints beautifully and prints fast, and I'm in love with it. It's really nice to have a modern 3D printer. Tyth says, grab the USB-C to micro B. You'll never have any more rarely used cables that still regularly saves the day. That is a good one. Let's see, what else? The PIO, let me pull this up and show you. PIO software serial for RP2040 is this, and I want to give a huge nod to Toddbot, for thinking of this as a possible way to get the Stemma cable to send and receive UART, because I don't think we have any chip in the QtPy form. Maybe I think there's a Metro that can do this. I think the Metro ESP32S3 can do TX and RX over the Stemma QT cable, but none of the QtPys have it set up that way as far as I could tell. So I was going to give up on using that cable, but I think Todd had an inspired thought when he went, wait a second, if you're on an RP2040, all the pins can be part of the whole PIO party, and sure enough, there's this PIO-based UART, and I think this is the question right here. When you initialize it, you do serial PIO, TX pin, RX pin, and I may be able to swizzle those. So on like the blue board, it'll be 2223. On the red board, it'll be 2322. Then it can be, you don't need the null modem crossover. We can just use a regular Stemma QT cable, but I think remove the red wire. I don't think we want to be sharing power like that, right? 5 volt. I don't think we want to do that. Okay, so that's the trick that's making this work. I'm excited about it. It is a really useful little gizmo for certain types of sound machine setups, and I will finish up my guide on the espresso tank water meter, and then get this going. And then we have some cool game-related stuff in the works that I'll be moving on to then after that. So, did I skip anything or forget anything? Before I go, I want to remind you, Fugue State, that is your coupon code for the day. By the way, Fugue Machine, I can't remember if I bought that or if that's free, the iPhone app. It's just called Fugue Machine. Go look for that if you're interested in that. It does have a built-in synth. It doesn't just have to send MIDI, so you can play a software synth on the iPhone, and I think it can act as a audio device. They don't call it a VST on the phone, but a audio unit. Is that what it is? Audio unit device, and feed any other synth pretty much that complies with that standard on iOS. So I think you can do some, use it as your sequencer to play kind of almost anything. Good. Okay. Let's see. Questions. Beta Graf Hagen said, past that you have to use contiguous blocks. Wait, is this a separate question? Might be. Or is it about the PIO UART? Because, yeah, sometimes these things have to be in pairs, and I just don't know if you can flip that pair to switch it around. Well, it says software serial PIO can both support inverted input and or output via the methods set invert RX, set invert TX. Is that just about voltage? That might just be about if it goes higher, if it goes low. Much to learn. Okay. So yeah, go to the store, grab some cool stuff. Fugue State will get you 10% off. That is going to do it for this slightly shorter edition. Thank you to C. Grover again. Pipes up with, you don't want to share power between the two powered hosts. And says it would be fun to design an opto-isolated stemma board. Yeah, and do check out some of the other cool stuff that Steve, okay, you're on the chats, has made for some related things. This is optically isolated, which is following the specs a little more closely of MIDI stuff. But he does have some other neat little gizmos for connecting up hosts to hosts and flipping TRS MIDI A and B, doing I2C to MIDI, which some of these sound computers want you to do. So lots of neat little solutions there from Steve. I'm also hoping to eventually get, I think it's in stock, so I shouldn't show it because I haven't ordered one, but I've been planning on getting, where'd you put them, under kits? No, under new. This little cool gizmo here is a Neotrellis, Adafruit Neotrellis, except with mechanical key switches instead of the membranes. So really cool remake that Steve did on the Adafruit Neotrellis boards. Runs pretty much the same. I think most of this is very similar, the same setup as far as stemma QT I2C, or regular size stemma 4-pin I2C, to build any of your Neotrellis kinds of projects, but with mechanical key switches instead of the membranes. So that's a cool one right there. And yeah, I don't get any kickbacks for this, but I think Steve makes cool stuff, so go check it out. All right, I think that's going to do it. So thanks everyone for stopping by. We'll be back with either Scott or Foamy Guy with a deep dive tomorrow. Possible Desk of Lady Ada over the weekend. I'll be back on Tuesday with product pick of the week. And then we'll have 3 Hangouts returns on Wednesday morning, show and tell that evening, and Ask an Engineer after that. So that's what we've got coming up in the live streaming. Thanks everyone for stopping by, and I will see you next time for Adafruit Industries. I'm John Park. This has been John Park's Workshop. Bye. You